Sarakarki, and in this video, I'm going to explain my machine learning practical on lung cancer risk classification. The main aim of this practical is to use patients-related information to classify lung cancer into three categories, that is low, medium, and high. For this practical, I implemented and compared three machine learning algorithms, that is logistic regression, KNN, and random forest. So at first, I imported the required Python libraries including pandas, numpy, matplotlib, seaborn, and the required scikit-learn module. Then I uploaded and loaded the dataset using pandas. After loading the dataset, I checked row, columns, and displayed the column names and viewed the first few records and checked the data type. After that, I performed the basic data exploration. I checked for missing values and duplicate records. The dataset didn't contain missing values, and the duplicate checking step was performed before removing duplicates. I also used descriptive statics and checked the number of unique value in the columns. The targeted variable in my dataset is level, which contains three classes, that is low, medium, and high. The original class distribution was the original class distribution in high was 365 records, and in medium 332 records, and in low 303 records. This shows that the three classes are responsibly represented in the dataset. After exploring the dataset, I removed duplicate records where necessary and checked for outliers using the IQR method here. Then I converted the targeted variable into numerical value. I mapped in such a way that for low it was 0, for medium it was 1, and for high it was 2. Then after that I separated the dataset into feature X and the targeted variable Y. Next, I divided the data into training and testing sets. I used I used percent training and percent testing splits with random states. I also used I also used satisfaction so that the three risk classes remained represent in both the training and testing sets. The test set combined 31 records with 9 low risk, 11 medium risk, and 11 high risk record. For feature scaling, I used standard scaler. The scaler was fed using the training data and then used to transform both the training and the test data. This is especially important for modules such as KNN because the feature needed to be on a comparable scale. The first model I implemented was logistic regression. I trained the model using the training data and then generated the prediction on the test data. The logistic regression module achieved 100% test accuracy. Then precision, recall, and F1 were also 100% accurate. Then the second model was KNN. I used 5 neighbor for this module. KNN achieved a test accuracy of 93.55%. Then precision was approximately 94.52%, recall was 93.55%, and F1 score was approximately 93.41%. The confusion uh, that's it. Then the third module was random forest. I used 100 decision tree with random state 42. Random forest achieved 100% accuracy as well as in recall and F1 too. Then after that, I after that here after that I compared the performance of all three modules where logistic regression was 100% accurate, KNN was 93.55%, and random forest was also 100% accurate. Therefore, logistic regression and random forest achieved the highest test accuracy, while KNN achieved a slightly lower accuracy. After that, I also performed five-fold cross validation to get more reliable estimate of model performance. The average cross validation accuracy where logical regression in logical regression it was 98.06 percent, KNN 94.26%. In random forest, it was 97.42%. Based on these results, logistic regression has the highest cross validation mean, followed closely by random forest. Then, uh, here is confusion matrix for logistic regression. Next, it is for KNN. Now, next, it is for random forest. Then here is the modal accuracy comparison. As I said before, logistic and random achieved the highest test accuracy, while KNN achieved a slightly lower accuracy. Then here is also one table for five-fold cross-validation performance. Then here is then I also generated visualization such as the risk level distribution and correction matrix. The random forest feature importance analysis was used to identify which features contribute more strongly to the module's prediction. This visualization helps to provide a better understanding of the dataset and the module results. Uh, and here I have done the comparison of all the classification again. Uh, and this is confusion matrix once again here. Here I have done overfitting analysis where it is where logical regression is shown. Uh, it's shown as overfitting. KNN is balanced, and random forest is also overfitting. Here again, I have shown the comparison of classification models on the basis of accuracy, precision, recall, and F1 for all three models. Likewise, this is the final evaluation. To conclude the practical successfully, applied three machine learning algorithms to the lung cancer risk classification problem. Logistic regression and random forest achieved 100% accuracy, while KNN achieved 93.55%. The cross-validation results also show the strong performance from logistic regression and random forest. Overall, the practical demonstration demonstrates demonstrate how machine learning modules can be used to classify patients into low, medium, and high cancer risk categories, and how different modules can be compared using accuracy classification metrics, cross validation, and module balance analysis.